Assalamualaikum. Today I want to present assignment which is BRC 3433 Computer Network and Security. So the title is BGP Pairing Perfect Filtering and Black Holing in Enterprise Multi-Homing. So we have three group members which is Muhammad Rizal Chin, Ashraf Dina bin Idris and Rishi Keshwara. So the first slide is introduction. To provide redundancy and load sharing, Skynet Industry runs a multi-home network that is linked to Internet Service Provider ISP. However, the company recently had a prefix hijacking issue in which Skynet IP prefix was mistakenly advertised by an external autonomous system as disputing traffic. The goal of the assignment is to use GNS3 to create a secure border gateway protocol (BGP) environment, setting up IBGP and eBGP pairing, properly publicizing enterprise prefix, and putting access control (SAL) based prefix filtering in place to listen prefix hijacking attempts are some of the goals. So this is the next network topology design. So this is IP address, internet IBGP link between R1 and R2. This is output for R1 and R2. This is R1 to ISPA. This is output. So this is output for R2 to ISPB. So this is a LAN subnet for Skynet, which is PC1 show the IP and PC1 to save. This is output for ping test on R1 to R2 and ISPA. So this is output. So this is output for ISPA to R1. So this is output for IP addressing for me. So I want pass to my friend to continue to my present. Thank you.
This is IP addressing for ISPA to R1. This is show you result. And then this is ping test on R2, on R2 to R1 and ISPB, showing the result. And the IP addressing show ISPB to R2. And this is a ping test for VPC for R1 and R2 IP address. And this is PGB configuration. IPPG pairing between R1 and R2 within AS65010. This showing result configuration. This is result for R1 and R2. Showing the result. Connectivity is up. And this is for IPPG summary and show IP for R1. And this is for R2. And the last is IPPG summary for ISPA.
Hi, I'm Mr. Keshwara. So I'll be talking about the IPBGP summary for ISPB and followed by the show IPBGP part as well. So this is the show IPBGP part. The top part is basically if you look in the output, look at the network, which is 192.168.10.0. That is the authorized Skynet LAN subnet. Basically, based on the symbol, the star and the arrow, it shows the root is valid. And then followed by the part number 65010I shows that this root is originated from the company's AS system, or also known as the autonomous system, and that proves that our BGP advertisement is reaching the ISP correctly. And then in the show IP BGP part, the neighbor 10.3.1.1, this is the router, which is R2, as seen from the ISP's side. And then AS 65010, this confirms the peering in between the ISP 65030 and the Skynet AS 65010. And then finally, we have it shows that the ISP is giving exactly two prefixes likely from the Skynet LAN and the other authorized link. This is the show IP to BGP for R1 and R2. So it has learned about the outside world via 10.1.1.2, which is via ISPA. And it has also learned about its parts via 10.1.1.1 via R1 for R2. And the B there symbolizes that the both table proves that the IBGP peering is working perfectly. This is the ISP-A and ISP-B show IP to BGP. And this is the final validation for our lab by showing the BGP routing tables of both ISP-A and ISP-B. And both ISP-A and ISP-B have the root of 192.168 .10.0/24 in their tables. This is the Skynet's LAN subnet, which is configured on our loopback interface. And as usual, letter B stands for the BGP, and that proves the ISP did not find the network themselves, but it went through the routers R1 and R2 successfully. As you can see, it is VR 10.2.1.1 and 10.3.1.1, and confirming the external link is active and carrying traffic. Then this is the ping results from the PC to ISP-A and ISP-B. As you can see, the PC is pinged to 10.2.1.2 and 10.3.1.2, and both sides is successfully pinged. Next, we have this prefix hijacking and security. So in this, we have created an ACL for both R1 and R2 that only permits advertisement of Skynet's authorized prefix. So as you can see, the first part that shows IP prefix list Skynet only permit this is only permit 192.168.10.0/24. That is basically where I created a prefix list that specifically permits that IP address, that subnet. This is for a more precise than a standard ACL for BGP routing. And then the part that shows the neighbor 10.2.1.2 prefix list Skynet only out. That is the application step. That part I have attached the filter to the ISP neighbor, which is 10.2.1.2 in the outbound direction, and that will ensure R1 checks every piece of routing info before sending it to the ISP. Next, we have the network part, 192.168.10.10. This confirms that the Skynet LAN is being successfully sent to the ISP. And finally, we have the total number of prefix, which is 1. This is the successful indication that proves that the filter is working perfectly, because only one authorized network is being advertised, and all the other internal networks are being blocked. And the same thing goes for R2 side also. So whatever is explained for in R1's details, everything is the same for R2 also. And so prefix hijacking is also known as through hijacking, which is a major security vulnerability where an AS falsely advertises ownership of IP address prefixes that it does not actually own. So how it occurs in BGP is that BGP exchanges routing information between AS on the internet and trusts the information it exchanges and receives, but it does not verify the ownership of the prefixes. So for example, if a legitimate network advertises an IP of 10.0.0.0/16, and a hijacker advertises 10.0.1.0/24, routers will always prefer the /24 advertisement because it is a more specific destination. ACL-based prefix filtering uses access control lists on BGP routers to control which prefixes are accepted from or advertised to the neighbors. So as for the conclusion, in short, the study emphasizes how crucial proactive BGP security measures are contemporary for business networks. And through this assignment, we have learned on how to illustrate how to use GNS3 to design and implement a secure multi-home BGP environment. Thank you.